So we're going to do this piecewise function, and notice this is defining the graph from -2 to infinity, basically. So the domain starts at -2. You'll see the red graph. I'm color coding this for you. The red graph is going to go from -2 to 0, and it's going to be filled in at -2, and it's going to be an open circle at 0. Okay. So, and notice that the graph is the absolute value function, which just is this.
Yeah.
Actually, it's just this right here. Right?
Yeah.
So one way you could do this is you could just graph it and then erase everything where it doesn't apply. So you could just do that. Like I could just erase that side.
Yeah.
And then I could put a big circle right there because remember, it's not defined there. And then I could put a circle right here and erase everything to the left of it.
Yeah.
So if you could see that, just do that. If you can't see that, plug in -2. Plug -2 in here. Whoops. Plug -2 in for x. Plug that in first, and then graph it, which you'd find is right there.
Yeah.
And then plug 0 in and graph it, but use an open circle, and then think what is between there. Is it a straight line? Is it a curve? What is it? And if it's an absolute value like that, it's a linear absolute value function, then you know that it's like that.
Yeah.
Okay. So that's that part, and let me clean this up a little bit. I'll make that more obvious, bigger hole like that. All right, the green part is just 1 point. You see how it's telling you that when x equals 0, y or f of x equals 1. So that's just that point right there. That's all it is. And the purple part is whenever it's greater than 0, it's the cubic.
Yeah.
So the cubic graph, remember with the cubic, it would go through 0, 0. But it's not. It's only for when it's greater than 0. So you keep that open circle there. And then it would go through 1, 1. And then it would go through 2, 8. So it would be way up high.
Yeah.
I'm actually not even going to get to it on this graph. So it's going to look kind of like a quadratic, but it's really not quadratic. It's really cubic.
Yeah, I see it.
So it's going to do that.
Okay.
Okay, so that would be the piecewise function for that. Let's try another one. So here's another one that you'll see. This is a little bit different. So first of all, notice that this is a rational function, the red one, and it's only defined when x is less than 0. So it's anything left of the y-axis.
Yeah.
Okay? And so what you could do is you could just start plugging in points kind of in your head. Like plug in 0. Are you allowed to plug in 0?
No.
No, so that's going to be a vertical asymptote if you remember rational functions.
Yeah.
And then if you plug in -1, what's -1 going to give you?
-1.
You're going to get -1. If you plug in -2, what are you going to get?
-0.5.
Yeah, you're going to get -1/2. If you plug in -3, what are you going to get?
-1/3.
-1/3. And can you see the pattern?
Yeah.
What's going to happen is it's going to be this. The asymptote is going to be the x-axis, and the asymptote going to 0 is going to be the y-axis. Okay, so by plugging it in points, you can kind of see what it does. Okay, and then what happens when I get to 0? What do they want me to use?
They want for 0 right here.
For 0, what should I plug in?
Positive.
What I get when I plug in 0?
You're gonna get 0.
0, 0. What do I get when I plug in, let's say 1?
1.
What do I get when I plug in, should I plug in 2?
No.
How about 4?
Yeah.
Pick a nice number, right? What's the square root of 4?
2.
Do you see what happens? So this is just that absolute value, or the square root function, which is half of a parabola turned upside down, turned sideways.
Yeah.
And there you go.
Okay.